In Activity 2 of Section 14, we're asked to look at two different structures for functions. We're asked to look at function rules or equations, and we're asked to look at tables representing functions. So the first round of the card sort activity was finding the x-intercepts. And then round 2, we're asked to find the zeros of the function. And truth be told, these are the same exact thing. If you're looking for the x-intercepts or the zero, we're effectively asking you the same question. So those are the ones there. We're going to go through those in just a minute and how we calculate those. And in round 3, we're asked to find the slope. Round 4, we're asked about increasing versus decreasing. And once again, these are essentially the same thing. A positive slope will indicate an increasing function. A negative slope will indicate a decreasing function. And then the last round, round 5, we're asked to find the y-intercept of the graph. So in other words, we want to know where does this graph cross the y-axis. So let's take a look at the different representations and how we actually find those. So in round 1, again, we're looking for the x-intercept. So we have a lot of these different representations here. And in order to find the x-intercepts, if we have a function rule, what we're looking to do is we're effectively just looking to find out where the output of the function is equal to 0. So we want to know where 0 is equal to 3x minus 4. So we're going to just solve that equation, add 4 to both sides, divide by 3, and we get 4/3. So that's why A was classified as a positive, because of the fact that when we solve it, we get 4/3, positive number. And then card B, same rules. We're going to take this 0 for f of x and set it equal to negative 2x plus 1. Solve for x, so bring 1 over to the other side by subtracting. We've got negative 1 equals negative 2x. And then divide by negative 2 gives us x equals positive 1/2. In the second round, in the tables, we're asked to find the x-intercepts using the table. So this is a little bit different line of thinking here to do this. What we're looking for, again, is where does that output equal 0? So if we looked at round A and round B, we knew that f of x was 0. So my first thought is to look on the outputs and look for a place where the output is 0, and I'm really not seeing it. So in this case, I need to think a little bit more in depth about how do we get there. So instead of actually finding the exact location where it is, we're going to find kind of an approximate area for where the output is equal to 0. So first I look from negative 8 to negative 2. Between negative 8 and negative 2, just looking at the outputs, there is no number 0 in between there. But if I look at negative 2 to 4, I know that somewhere in here my output will equal 0. So then the trick is looking back to the inputs and trying to figure out where that actually is. So if the output is 0 in here, that means somewhere in here there's an input that made it happen. So if I've got the numbers here 1 and 4, the numbers between 1 and 4, well, they're positive. Again, I don't know exactly what the intercept is, but I have a pretty good idea of where it is. It's somewhere in this range between 1 and 4, and it's got to be a positive number. On card H, we're going to follow the same line of thinking. So from between 9 and 3, I don't have a 0. Between 3 and negative 3, I do. So somewhere in here, the output is 0, and we're looking for the input values that made it happen. So we know that somewhere between 1 and 3, some input gave us an output of 0. Doesn't necessarily mean it's directly in between, but it's somewhere in that range. And I know that positive 1 and positive 3, the only type of numbers in between there, have to be positive numbers. And that's how we're going to look at a table to find the x-intercepts and also the zeros, which again is the same thing. In the third and fourth round, we're asked to find about increasing and decreasing, and also the slope. So round 3 was actually technically the slope, and then we use that for increasing and decreasing. Again, if we have a function rule, that's cool because the function rule, f of x equals mx plus b, that structure tells us exactly where the slope can be found. The slope is m, and it's that number directly in front of x. So this question right here said f of x equals x minus 2. I put a 1 there just to make sure we know that there is a coefficient of 1. That's my slope. Now if that's a positive number, that tells me that that function is increasing in that interval. And in f, we did the same thing. F of x equals, now in this case, 0x plus 5, because it's not there. It's just a 5. So that means there's a 0x there. Again, the number in front of x is 0, so the slope for that would be 0, which is neither increasing or decreasing. If I'm looking at the table, there's a couple ways to do this. One is to actually like pick all these points out. Take -3, 7, 0, 1, 2, -3, and use the slope formula. That's certainly a possibility. But again, I think formulas we tend to forget, but patterns we tend to see forever once we get it. So if I'm looking at this as the output and the input, the slope is really the change in the output over the change in the input, over the same like intervals. So if I'm starting at the top here and I go from 7 down to 1, that's a pattern of dropping 6 or subtracting 6. If I'm going from -3 to 0, I'm adding 3. So the change in the output is -6, the change in the input is 3, so I'll have -6 divided by 3, which is -2. And same thing for the other one. If I wanted to pick the other points, the 1 and the -3, I could do that. So my output, the change is -4, and my input has a change of 2. -4 over 2, that gives me the same thing. Doesn't matter if I go the beginning to the end as well. It's the same slope. So same thing on k. We do -4 to 2, that's a +6. And 0 to 2 is a +2. 6 divided by 2 gives me 3. And in round 5, we're asked to find the y-intercept. The y-intercept, if it's in a function rule, again, fairly easy to pick out if we understand the structure of the equation. We have f of x equals mx plus b. This guy right here, the b, that's your y-intercept. So when I find this f of x equals -4x minus 3, b is right there. And in c, we had 5x. There's nothing after that, but I can write it as a plus 0. That's my y-intercept, plus 0. And then in I and j, we're asked to find the table. So this is kind of backwards thinking from what we did for the x-intercept. Now instead of wanting the output to equal 0, we want the input to equal 0. J is the one I'm going to focus on first. And if I look at j, the input here is -2, 0, and 1. Oh, there we go. I have an input that equals 0. My output for that is the y-intercept, which in this case is 2. So I classify that one as a positive y-intercept. And then in I'm looking for where we have a range, because I don't see an input here that directly equals 0. But I know it's going to occur somewhere in here, between -3 and 1. So in between -3 and 1, I do have a 0. I want to know what the output will look like at that particular place. So the output is going to have to be between 0 and 4. So again, input here is a 0, somewhere in there. And the output is between 0 and 4. And that would definitely be a positive number. And for the closure of this section, it's essentially just a review of what we've done from the beginning. Those graphs should look familiar. They were the beginning of what we did for the warm-up. Again, 3 different representations. We've got the graph representation of function in A and B. We've got the table representation in C. And then we have the function rules representation for D and E. And I think really the key here is being able to look at all 3. But essentially, if you have a particular method that you like, you can always use that. We have found that looking at the graphs is probably the easiest to determine the answer to these 3 questions. So it is possible that if you had C, you could take those points and plot them and get a pretty good idea of what the graph's going to look like. And then for D and E, you can also use your graphing calculator. Again, type the function into y equals, hit graph, and it will graph it for you, and then you can analyze it from there. But again, question 1 is looking for decreasing, so we want to know where's the slope negative. Question 2 is asking for where we have a positive 0, or in other words, a positive x-intercept. And question 3, where do we have a negative y-intercept? So where does the graph cross, as a negative value on the y-axis.